Hello everyone, and welcome to another in our series of videos about functions. Now, we're going to start to get more specific now. We've talked about functions in general, domain and range, etc. But now we want to narrow this down to specific types of functions. So I've got two on here. I've got two different sets of rules. The F machine takes numbers and then multiplies them by 2 and then adds 1. The G machine's just like that, but it does one extra thing. It takes a number and squares the number first before it multiplies by 2, and then it adds 1. That's all there is really to this. So I'm just going to write down some data here. So I'm going to start off with this one, and I'm just going to put in minus 1, 0, 1, 2, and 3. So when I put in minus 1 here, multiply by 2, and add 1, I'm going to get minus 2 plus 1, which is minus 1. Next time, I'm just going to take my number, multiply by 2 like I do, get 0, and then add 1, and I'm going to get 1. Here I'm going to take the 1, I'm going to multiply by 2 to get 2 and add 1, which will give me 3. I'm going to take the 2 and multiply by 2 to get 4, and then add 1 to get 5. I'm going to take the 3, multiply by 2 to get 6, and add 1 to get 7. Now over here I'm going to do the same kind of thing. We'll use minus 1, 0, 1, 2, 3. We'll throw in 4 as well on this one. And we're going to get minus 1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. Here I'm going to put in 0. 0 squared is 0. And 0 times 2 is 0 still. Plus 1 is 1. 1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. We get this 2. 2 squared is 4. 4 times 2 is 8. And 8 plus 1 is 9. I'm going to get 3 squared is 9. 9 times 2 is 18. And 18 plus 1 is 19. 4 squared is 16. 16 times 2 is 32. And 32 plus 1 is 33. Okay, so now what we want to do is we just want to look at how the outputs are related to the one before it. In other words, what do we do to get from here to here? Is there some kind of pattern to go from one number to the next? Well, to go from minus 1 to 2, you've got to go from minus 1 to 0, and then from 0 to 1. So we're going to go up 2. To go from 1 to 3, we're going to go up 2 again. And from 3 to 5, we'll go up 2. And from 5 to 7, we're going to go up 2. And you notice these are all the same. And it wouldn't have mattered what equation we started with. We would have got the same pattern, that we go up by a consistent amount, as long as we're always just multiplying numbers and adding numbers. Okay, we get the same thing. Now, if we go over here, let's see what happens here. We go down this time by 2. Then we go up by 2. Whoa, now we're going up by 6, up by 10, and now we're going up by 14. And there doesn't seem to be a pattern here at all. These are definitely not the same. But now, when we look at these ones are related. What happens here? We go up 4. We go up 4 again. We go up 4 again. We go up 4 again. And these ones are the same. And again, it wouldn't matter what these numbers were. This comes from the fact we're using this machine, a squaring machine. And whenever we use a squaring machine, if that's the biggest thing we don't use a cubing machine or something like that in there, then we'll always get this pattern here. So this comes from a squaring machine, which we call quadratic. This is a quadratic function. And this one here we call a linear function. Okay, so for a linear function, this first time you do this, they all end up the same. So the first differences are the same. Okay, so let's just wrap this up by just making a quick conclusion. If the first differences, we'll just be lazy there. If the first differences are equal, put an E there, equal, then linear. We'll be even lazier on this next point. Second differences equal than quadratic. Just a quick way to identify that if you get a list of inputs and outputs, you can tell whether it's going to be quadratic or linear. If it doesn't end up being either, then we just say for now that it's neither linear nor quadratic.